Good evening, everyone. So today we are going to start a very high yield topic that is called as resonance. This is also called as conjugation or delocalization of pi electron. So resonance or conjugation or delocalization of pi electron. In DAT, questions from resonance, the one it can be from identification, second from pi electron, third resonance structure and stability. RS means resonance structure, and fourth its application. So in today's session we will discuss how to identify resonance in a compound. So let's start identification. Of resonance. Before starting this, we should know conjugate species. So we can say the species which is responsible for resonance is called as conjugate species, and these species are positive charge, negative charge, lone pair, radical, double bond, and in the last we have vacant orbital. Okay, again listen me. I said positive charge, this is called cation. Next, negative charge, this is called anion. This double dot is called as lone pair. And this single dot is called as radical. And the vacant orbital, this is vacant orbital like boron, phosphorus, and we have to consider only vacant P and D. Aluminium as well. These three are very important, okay? Boron, phosphorus and aluminium. So let's start how we can use this information in identification. Again listen me. Now there is a condition of resonance. Here we can say conjugate species must be in alternate position. So this is a condition of resonance. Means between two conjugate species we should have a single bond. This is called condition. And conjugate species is what? Positive charge, negative charge, lone pair, radical, double bond and vacant orbital. So if these species are in alternate, then that is called as resonance. Look at example. So as you can see, this positive charge is a conjugate species. This double bond is also a conjugate species. And here we have a single bond. So you can see it is separated by a single bond. It means it is in resonance. Another example. Suppose this one. So you can see this is a conjugate species, this one is also a conjugate species, and we have a single bond, means resonance. Positive charge is a conjugate species, this is also a conjugate species, and this one is also. And you can see everyone is in alternate, means this positive charge and this double bond have a single bond, this conjugate species and this one we have a single bond, and this conjugate species and this have a single bond. It means this is fully conjugated system. If you have this one supposed to be, you can see this lone pair is a conjugate species, this one is also a conjugate species, but here we have two single bond. It means it is not in resonance. It should always be a one single bond. Okay, let's discuss few more example. So look at here, radical is a conjugate species, double bond is a conjugate species, and here we have a single bond. It means resonance. Double bond is a conjugate species, this double bond is also a conjugate species, and here we have a single bond, resonance. Lone pair is a conjugate species, this double is also a conjugate species, and here we have a single bond, so again resonance. In D, lone pair, anyone, you can see this is a conjugate species, double bond is also a conjugate species, but here we have two single bond between them, it means no resonance. Double bond is a conjugate species, positive charge is a conjugate species, again we have two single, no resonance. Negative is a conjugate species, double bond is a conjugate species, and yes, we have a single bond, so resonance. So this is the way we can identify resonance in a compound, and this is very, very important, because in the next session, once we are going to calculate the pi electron, then it is very important part. Thank you so much for watching this.